Is the substrate. And as you can see, we have all of the most common substrates for wipers. From a non-woven, lightweight polyester, standard weight polyester, laser edge, standard weight polyester, pressure heat seal edge, polyester wiper with conductive filament, cotton wiper, and microfiber wiper. Let's talk a little bit about the pros and cons of substrates. First, let's start with a non-woven wiper. As you can see, a non-woven wiper has what we call a machine direction, where the fibers run this way, and a cross direction. So if I may have some audience participation, can you grab the corners and we're going to pull. You see, when we pull in the machine direction, the wiper is very tough. But now let's take the opposite corners, and now we're going to pull this wiper in what we call the cross direction. And in the cross direction, what do? We just had a catastrophic event. The wiper broke down and we released fibers. And so this also relates to cost. The non-woven wiper is also the least costly because it's primarily wood pulp, and there's just enough polyester that gives it some strength, but clearly not enough strength. So the pros and cons of the non-woven: it's highly absorbent because the cellulose, which is wood pulp, is absorbent, but it doesn't have very high tensile strength. And there's decent tensile strength in the machine direction, but when you go cross direction, you see how the wiper just breaks down and you have a catastrophic event, which you don't want to have an event like this in your controlled environment. So next up, probably the most common grunt wipe for an entry-level wipe or a multitask wipe is the non-woven. Non-woven is the most common wiper material for spills, for non-product contact, wiping down floors and walls. One step up is a polyester lightweight. And this polyester lightweight is woven in an X and a Y. It's not interlocked, so there's no Z. There's no diagonal strength to it. And you can see one way, the machine direction, it doesn't stretch much. But the other way, the cross direction, so I'm going to ask you to really pull on this, and you can see what happens is it actually starts to run, okay? The reason why it runs, and you can see here along the top, the beginning of running, is there's no interlock in a lightweight. And so that's an obvious concern with this substrate material. It doesn't have the interlock, which there's no reason to prevent it from running, but because it doesn't have that third layer, it just has an X and a Y and no Z, you don't have as many crevices for absorbency. One step up would be the VTP&W. The VTP&W has an X, Y, and a Z, and if we can illustrate with this wiper, you can see the machine direction and the cross direction are very similar, okay, because it has the Z in it. And the Z basically prevents the wiper from running, okay? So this wiper has an interlock, so it's not going to run, standard weight. Then the only difference between the VTP&W and the LS and the PHS is just the cut or the edge treatment. So it's the same substrate material. If we go up to the polyester with the carbon fiber, again, it's basically the same substrate, but what we've done is we've added carbon fiber. And what the carbon fiber does is it will take a charge and it will dissipate the charge out through the carbon fiber. So this is a wiper that's ideally suited for ESD. Normal polyester wipes are not ESD compliant because they will hold a charge. A polyester cellulose, because it has a high amount of cellulose, which is wood will conduct, okay? So a non-woven is a good ESD safe wipe. A standard polyester wipe is not ESD safe. But if you want to have the cleanliness of polyester, you can go with polyester that has been enhanced with a carbon strip. Then, cotton. Why would someone use cotton? Well, it is highly absorbent, like non-woven, because the fiber itself is absorbent. But cotton, because it has that open fibrous structure to it, the molecular structure, when you agitate a cotton wiper, it's going to release particles. And remember when we discussed cost, cotton is one of the most costliest wipers. So it's very expensive, highly absorbent, but it's also fairly dirty. But it's one thing that polyester is not. If you put a cellulose wipe around a high temperature, it's fairly high temperature tolerant because it's wood pulp. If you put polyester around heat, If you're welding stainless steel, or if you're dealing with very hot parts, or you're on an oven, you're going to have your polyester wiper fuse. It's going to bond itself to the hot subject. So polyester is not at all heat tolerant, where cotton is very, very heat tolerant, right? And so the most common application for cotton is where someone needs a wiper that's very absorbent and that's very heat tolerant. Because you can have a cotton wiper come in contact with a very, very hot part, and the wiper will not melt too. The wiper will actually convert to ash, and so you're not going to have any bonding. And then the most expensive of all substrate materials, and the most unique, is microfiber. Microfiber, standard wiper polyester yarns look like this. That's what a standard polyester yarn looks like. It's monofilament. What a microfiber looks like is it's much smaller, and that is the polyester, and then this is the nylon. And remember when we talked about cleaning a surface, a wiper that has more texture is going to be more effective cleaning. And a monofilament, this is a pretty large fiber, if you put a lot of pressure with a polyester wipe on a very delicate substrate like a plastic or an optic, polyester can and will scratch. If you look at the edge treatment, this can and will scratch. Or a microfiber wiper, because it's a smaller strand and it's excuse me. And the thread is a combination of nylon and polyester. What you're going to have is you're going to have a wiper that has much better texture to it, and that's going to be soft. So you can take a microfiber wiper and put an incredible amount of pressure on an object, and it will not scratch it. So there are many choices as it relates to substrates. There's a polyester cellulose, which is highly absorbent, highly heat tolerant, ESD safe. It's actually similar in performance characteristics to cotton. The reason why we don't see cotton very prevalent anymore in the industry is cotton is very, very expensive. But it's also heat tolerant, highly absorbent, but like the non-woven, not very clean. But the non-woven is far and away the grunt wipe. It's the multitask wipe. It's the most common wiper used in a clean room. And then the most common wiper substrate for critical cleaning is polyester. And you're basically going to have the choice of a lightweight polyester or a standard weight. Standard weight's preferred because it's going to have more absorbency because it has more layers. It is also going to not run because it has that interlock layer. And then the choice really with polyester, once you go beyond the basis weight and the weave, is going to be a knife edge, a laser edge, or press or heat seal. This is a little bit of an outlier. You don't see many people that the setting for this would be a setting that you needed to have something very, very clean and also an ESD safe wiper. They're going to be using a polyester wiper that has a conductive filament in it. And then really the most effective of all cleaning wipers is the microfiber. I didn't talk about the 2-ply, and I should address the 2-ply very briefly. The 2-ply is really a hybrid. The 2-ply is two standard 8-weight wipers that we fused together. I don't really call it as a different substrate because it's really just a modification of the VT-PNW. We've taken two of them and we've sandwiched them together, and that's what the VT2PNW is. It's not a different substrate, but by combining two wipers together, we have more absorbency in one 2PNW than you would have in two just standard VT-PNWs. Thank you.